All right, thank you very much. First of all, before I start, I just wanted to say thank you very much on behalf of all of product development, product management, and in fact, the entire company. Thank you for taking the time out this week and spending a couple days with us. The conversations and collaboration and discussions we have is the single biggest thing that informs our roadmap and our priorities of what we do, and we really, really appreciate the time. We also understand the opportunity cost of spending a couple days with us this week out of your busy schedules. So with that, let's talk about the products and technologies a bit. One thing we've done is we've segmented our technologies and solutions into effectively a stack of building blocks, as John mentioned, a toolkit. So I'd like to go through some of this toolkit and then end with a technology demonstration that demonstrates major components of this toolkit. So first and foremost, on the bottom, you've got the fabric. This is basically the platforms, the software platforms, and the services that make up the core part of the platform or the fabric that implements parts of the F5 solution. On top of that, you have the ecosystem partners. So these are other platforms. These are partner platforms that we sit on top of that we need to interoperate with and work with. On top of that, you have the interfaces, connectors, and tools, which I like to call this the layer of glue. This is a layer of connectors and APIs and things that actually make the solution work and glue it to orchestration engines and automation technologies. And then finally, application services, right? This is what creates the ability to speed up applications, to secure applications. So let's take a look at each one of these layers in a little bit more detail from the bottom up. So first of all, the fabric. So on the left there, you can see one of the core pieces of the fabric is the Big IP I series. So this is the 2,000 through the 10,000 platforms, as well as a variety of variations to those platforms that will come out over the next year. Next to it, you've got the Viprion chassis, all the way from the 4-blade chassis to our 8-blade terabit chassis, which one of the big use cases for our terabit chassis is the carrier class firewall that sits in the GI core between the radio network and the internet. But any kind of workloads that need hundreds of gigabits and even terabit kind of performance, that's the solution. Right next to that, you have the Application Services Proxy, the ASP. This is the smallest thing that we've just released earlier this quarter that is a very small, lightweight proxy that sits in between containers and can sit inside microservice environments. Right next to that, you have the virtual editions. The virtual editions is effectively the software solution, everything from the trial version up to 10 gig version and the 40 gig version, which we released earlier last quarter. We also have a 100 gig version of the virtual editions in the lab right now for release later this year.
So Ryan, can I ask you a question?
Sure.
So you've got all these different flavors. How do you manage to keep track of which platform has which feature?
John, actually that's a good question, and actually I get that question a lot. It's important to realize that our software is common across all these platforms. So the software that implements the services, it's the same set of software, everything from the fixed switches to our chassis to the tiniest virtual editions. It's the same software, and that's actually important as customers move or use these different platforms at the same time for common services and security implementation. I'd like to end on that last bullet there, or that last box there, as Silverline. So this is F5 as a service. That's also a critical component of the platform. DDoS, we've implemented DDoS as well as Web Application Firewall Express technologies there, and look for more services enabled on that platform, throughout the year. Okay, so moving up the stack a bit, ecosystem partners. So this is the component of the toolbox, actually, that implements implements partner ecosystems and partner platforms. This is where public cloud and private cloud technologies sit in this segmentation. So things like Amazon, Google, Microsoft Azure, support for those platforms are there. Things like OpenStack, and VMware on the private cloud side are there. One of the big components of this from a product development perspective is the testing and certification beyond the initial development of these platforms. And if you think about it, our versions in Big IP go through a variety of version changes multiple times a quarter. And these ecosystems are also versioning multiple times a quarter, if not year. And so one of the big things we do here is we put a lot of effort and focus on the certification and testing of these ecosystems. So all these permutations are rock solid and high quality. I want to mention one other thing about this is the primary use of our platforms in these environments is the virtual edition. And historically, we've had bring your own license, and we've had, in some cases, utility billing in the public cloud. But as Francois mentioned yesterday, we've just in the last week released subscription offerings on our virtual editions too, which is a very valuable way to consume the virtual technologies in these ecosystems.
So Ryan, as the number of cloud providers is consolidating, do you anticipate that the ecosystem partners are going to consolidate as well?
I wish, John. I wish that was the case. What we're actually finding is every one of those ecosystems that we listed up here are being used by our customers today, and more are on their way. And one of our visions is to follow the applications no matter where they go. So as customers move applications into even more extended ecosystems beyond these, we will go there too. Okay, so move up the stack one more time with this segmentation. We've got interfaces, connectors, and tools. So this is where I like to call this kind of the glue layer, but this is where orchestration technologies like Chef, Ansible, and Puppet, and by the way, I do want to call out Puppet as partners and sponsors of this event who are here today, as critical technologies that we integrate with, we test with, we integrate with, and we've got a variety of customers using these orchestration technologies to help orchestrate and manage our products. In addition, microservice environments like Mesos and Kubernetes sits in this segmentation. And we've just released, or actually not just, but earlier this quarter, we've released the container connector, which actually sits inside microservice environments, Mesos and Kubernetes, and helps orchestrate both north-south big IPs that are front-ending these environments, as well as the application service proxy that sits inside. Moving to the right, there's some additional technologies here, IAPS and cloud templates. IAPS is a technology that is used to take a relatively complex configuration, powerful but complex configuration, and snapshot it up and simplify the interface to it. Simplify both the graphical user interface, if a human is interacting with an IAP, but probably more importantly, simplify the API and create a service level API such that orchestration engines sitting on top outside can see our technologies in a much simpler way and be able to orchestrate in a much simpler way. That's the IAP technology. And finally, I'd like to leave you with one more technology component of this layer, and that's the app connector. As Calvin mentioned yesterday, the app connector is a key new tool, actually, that bridges public cloud infrastructure to your private cloud and or on-premise infrastructure, basically extending a big IP, again, whether it's in a colo, whether it's on-premise, extending that functionality and visibility to the public cloud. So you can actually run true hybrid private public cloud environments.
So Ryan, in that environment, you mentioned Puppet, one of our sponsors. In that environment, could you use Puppet to orchestrate Container Connector or maybe Application Connector to go and get services from different public clouds, those types of things?
John, exactly. That's one of the exact use cases, is these automation frameworks and integrations with these work with and between each other. In fact, they work with and between all parts of that stack, that list of stack that I showed you before. So absolutely. So. Okay, finally, the last component in this segmentation is the application services themselves. So this is actually a subset of F5's services that are ultimately helping make applications faster, smarter, and safer. On the bottom, I won't go through all these, but you've got the critical security services like DDoS, web application firewall, firewall anti-fraud. You've got the critical core ADC services like application load balancing. iRules is the ability to interact with any of these services and extend those services into use cases and customized areas where product development we can't predict what might need to happen. And then finally, advanced protocol support. So protocols like HTTP, TCP, SSL we're constantly innovating new algorithms and new interoperabilities within these protocols actually, as the markets and technology changed. One thing I'd also want to mention here is IoT. You see IoT in this space because earlier this year, we've recently come out with MQTT support, which is protocol specifically to IoT workloads. And that's a big focus area for this part of the segmentation going forward.
Ryan, I see WAF up there. And we just got recognized by Gartner for the capabilities of our WAF product. And a lot of our customers in this room are probably using it in the on-premises environment. How does that help us with all these services? Can these migrate freely back and forth from public and private clouds?
Yeah, absolutely, John. In fact, as I mentioned before, all of these services are sitting on top of our TMOS traffic management operating system and the big IP software layer, and in addition to that big IP software layer is sitting on top of all of the fabric components, all of our hardware, of our software, of our virtual editions, which also sit on top of all of our ecosystem partners' technologies. So absolutely, and that is one of the key use cases of our multi-cloud technologies, to be able to use all of these things in common across all the platforms. Okay, so with that was the 10-minute, what does F5 do? Pretty tricky. What I want to do now is switch to a technology demonstration. And we're going to demonstrate some of these technologies I just reviewed and just talked about. We've underlined in red some of the things here that we'll be demonstrating, actually. So before I do the live demo, and John, I don't know if you should stand too close to that laptop. You can back away a little. So that's the
sales,
demo.
I can do a demo.
So all right, you're making me nervous. So. Okay, so before I do the demo, actually, I'd like to just explain what you're going to see in the demo, so it's obvious what's happening. So this is actually a portal we built. Our sales engineering community with F5. I want to thank them, by the way. They built this. Tony Marfil is here today, who actually helped make sure the demo is actually running. I want to call him out and thank him very much. This is a portal that was implemented and developed that sits on top of all those building blocks and tools I just showed you. What you're basically looking at here is a portal that in the lower left quadrant shows a topology, a picture of the demo. In the upper left shows kind of a command and control, ability to control the demo. And on the right side of the screen, you can actually see the live application as it's being requested and responded to. This is a live application. Let's just look at these a little bit closer. So again, in the lower left corner, we've got the topology itself. We've got 3 different topologies here: a private cloud topology and 2 public cloud topologies. In addition, we've instrumented the demo with the ability to show the status of each part of the topology. In this case, you can see that the private cloud part of the topology is live and running in green, and the other 2 are offline. In the upper left, as I mentioned before, is the command and control. Here you see we've got 3 applications. Might be hard to see, but we've got basically 3 applications that can be enabled and disabled and managed separately. Moving to the right, we've got the ability in this demo actually to bring on server infrastructure or to remove server infrastructure from the solution. In addition, in the right side, you've got the application itself, and we've watermarked the application components to show you which server is responding to different parts of the application. So 1, 2, 3, just showing you what server is actually implementing those. Moving to the right again, we've instrumented this portal actually to enable and disable a DDoS web application firewall policy. Right? So we're going to be implementing a DDoS attack on the system. We'll show you what that looks like, and then we'll be mitigating it by enabling a policy. And finally, we have the ability to enable an identity and access management policy. So the first parts of the demo will be unauthenticated. We'll see the application unauthenticated. We'll enable identity and access, and as you might expect, we'll see a login page. I shouldn't have thanked the SE group quite yet till the demo actually works, but yeah, I just realized that was wrong. But it's going to work, so all right. So with that, actually, I'm going to cut to the demo and show you live what this looks like. Okay, so the first thing with the demo is everything's off right now. So first thing I'm going to do is enable traffic to start. So behind the scenes, by the way, this demo is all simulated within the laptop. There's multiple containers and virtual machines inside this laptop that's actually hosting this demo. So this is a real demo, virtual editions, server infrastructure, as well as client-side traffic generators are being used to implement this demo. First thing you can see is the big IP versions on the left are up and running, and we have one server serving the application. We also have some client requests responding, and you can see on the right side the application is actually responding with server 1 implementing. So the first thing I'm going to do is just bring on 2 more servers under this demo. So again, your private cloud environment on the left, 2 more servers just came online. The demo now is actually, the server infrastructure now is actually feeding all of the components from all 3 of those servers. You can see that on the right now. The application is actually now showing you which server is responding to which of the applications.
So you're scaling the on-premises data center
exactly.
And automated, okay.
Yep, exactly. Okay, so now I'm going to show you switching this infrastructure to a public cloud. Now, for a lift and shift use case, this is exactly what you might do. You might set up the infrastructure in the public cloud. It's ready to go live. Create some kind of orchestration portal, ability to move traffic from on-premise to public cloud, and make sure it works with instrumented traffic and other things. So I'm going to move this infrastructure now by effectively to the Amazon infrastructure, which I just did. So you can actually see now the traffic. We're using DNS to switch over. The traffic now is actually 100% moved now to the Amazon Web Services. So this effectively implements inside this laptop, but a lift and shift.
Now we have a lot of customers that are building out nominal capabilities in their, or standard load capabilities in their on-premises data center, and then in times of burst. So for instance, tax authorities that at some time of year they get a lot of processing, or retailers during the Christmas holiday season, that kind of stuff, and so they all of a sudden need to move workloads. Is it that easy? Is that how it works?
That's exactly right, John. That's one of the major use cases, is the bursting use case for phenomenal capacity set up in one infrastructure, but the ability to burst and extend that infrastructure for some kind of temporal time period for bursting. Other use cases are disaster recovery and many others. So, okay, so with that, I'm gonna actually I should go back to full screen mode here. Okay, so with that, I'm now gonna so one thing we know, we've just moved our infrastructure to the public cloud. One thing we know that's guaranteed now is free penetration tests that happen on our public cloud infrastructure. Free denial of service attacks that will happen on your public cloud infrastructure. There probably was a perimeter somewhere supporting your private cloud infrastructure. There is no perimeter now in the public cloud. So we're gonna instrument a DDoS attack on this infrastructure. Now, I know most of us subscribe to denial of service attacks. You wanna, like for instance, that's one thing that when my kids are, not behaving well, I DDoS their phones and other things like that. So I subscribe. So lately, I've just been subscribing to a service. I get so many credits to launch DDoS attacks every month, but I'm out of credits right now. Like, it was a long, hard week with kids last week.
Sounds like it, yeah.
I'm out of credits right now. So we're just going to simulate the DDoS attack inside this laptop. So unfortunately, I won't be able to show you. We're going to do that with JMeter. So I'm going to initiate with JMeter. I didn't mention this, but before you were seeing about 6 transactions per second of good put, effectively. We've now just initiated a DDoS attack. We've just done 1,000 times more workloads. So we're showing now about 1,000 transactions per second and lots of additional packets per second hitting the front end. In addition, our web app firewall is actually detecting right now that we're probably under attack. actually. So we've instrumented the portal to actually show you this. This is actually one thing that the web app firewall, instead of going into mitigation mode, it can just be in monitoring mode. It could, at this point, signal Silverline to front end this denial of service attack, move traffic through Silverline to scrub that information or those connections before it comes back to this. So one of the things I'm going to do now is implement now the web app firewall enforcement with the demo. So I don't know where the app went. Let's see. Okay. Okay. One quick second. Don't quite know what. Well, you know this is a demo because that is incredible. We tested this like 20 times yesterday. What you should be seeing here now is
Maybe it's supposed to do that.
I can't believe this. What you should be seeing here is when I enable the DDoS profile here, you should be seeing the good put come down to, okay, maybe just wait a minute. Okay, there we go.
Something's happening.
Something's happening. Okay. One more thing. Okay, maybe it's stabilized. We're currently under a DDoS attack still. You can still see thousands of transactions per second hitting that front end. I'm going to enable the web app firewall policy. Come on, you're coming.
Good sign.
Okay,
that's a good sign.
So what you're seeing now is in the transactions per second, you're actually seeing the web app firewall policy now mitigate the DDoS attack. You should now be seeing the 5 to 6 transactions per second of good put, and the web app firewall now is mitigating and denying all the rest of the DDoS attack connection. You can also see on the packets per second side that those packets are still hitting the front end big IP, right? But they're just being blocked, so only good connections are going to the.
Now, more than 50% of the web traffic today are bots, and not all bots are bad bots.
That's right.
So how do you know you're not blocking everything like the volumetric DDoS tools do?
Yeah, no, that's a good comment, John. Traffic on the internet is significantly bots, 50% or more. So our technology, there's a lot of technology that uniquely identifies good bots versus bad bots and fingerprints bad bots, actually. So that's a significant part of our technologies, understanding which bots are actually attacking the infrastructure and denying only the bad bots. Okay, so the final thing I want to show you in this demo is implementing an identity and access policy on this. So one of the use cases, again, is you're moving your infrastructure potentially to the public cloud, as I've demoed here, but you want to enforce identity and access maybe from your local enterprise credentials or your local LDAP store. So I'm going to enable now identity and access policy on the application. The first thing you'll see is traffic drops to 0 because the robot, no responses now can effectively get through. It's every single one of our robots now is sitting there at the login page.
So in the on-premises world, you have a natural way to block network access. In this case now you're replicating exactly the same credentialing into the public cloud.
Exactly, yeah, absolutely. So I'm going to log in here. And voila, your access through the application. Now, one thing you'll notice is the bots, it's still 0 transactions per second because a simulation is now stuck behind the scenes. But I as a user, have authenticated, and I'm in, and I'm actually, application is up and running. So that's the demo.
Wow.
Yep. All right, I do want to finish on the toolkit again. And I want to comment on next. Okay, so I do want to finish basically with this toolkit. And there's one layer that I didn't show earlier, and that's the management and orchestration layer at the top. So what we just demoed is that right thing, a third-party portal that was developed for centralized management and orchestration of the ecosystem, of our app services, interfaces, and effectively the fabric. But another thing I wanted to call out that sits on top, in the top management level is our BigIQ. We just earlier this year released BigIQ 5.2, which has some major new functionality. A security certificate manager. It's got a major component now of metrics and analytics that are embedded in BigIQ, and we've made some pretty big progress on the scalability with BigIQ. The 5.3 version, which we just released literally just about a week and a half ago, extends use cases across the board and also makes additional performance and scalability improvements. So we're pretty happy with what's happened with BigIQ in the last year and really extending use cases and efficacy of BigIQ. So with that, I want to finish and say thank you very much. And actually, just John, is there anything else I can do to help you with your presentation today?
No, but it takes a lot of courage to come up here and do a live demonstration. How about one more round of applause for Ryan?
Thanks. Thanks, John. All right.
Excellent.
Okay.
Thank you.
Yeah, thanks.
Well, what you saw there, I hope you agree, it was exciting. It's easy. You can start to get the feel of how you can automate workloads between different clouds, both public and private. And not just automating those workloads. What you see is that the ability to replicate all of those things that you've already put so much energy in, all those security postures and certificates and different configurations that you know work, being able to move and migrate those easily from cloud to cloud. But it's not just about the automation element. And what we talk about a lot is just exactly how much flexibility do you need when you're moving these workloads. And you heard a lot of the speakers this week, the last 2 days, talk about how complicated some of this is. And just like in that Mercedes engine, like you need to understand the 2,400 codes that it's going to be spitting out, but we also still need to understand how a combustion engine works and how the timing of the engine works and how a distributor works and how oil flow works and gas mixture and all those kind of things. We have to know all of these elements to be successful. And a question always comes to my mind is, can too much automation be a bad thing? Because in a lot of cases, when you're talking to people about the cloud, it is presented in a way that makes you think perhaps that it's easier than it really is. And I would argue that yes, too much automation can be a bad thing. And I have an example for you here. And that's the sink in a public washroom. Now, I want you to put yourself in the position of approaching that sink. And I want you to think about the frustration that sometimes boils up when you fidget and you grope and you wave your hands to try to elicit just a few drops of water in what really turns out to be nothing more than a futile rain dance. Why is there no handle? I mean, sure, somebody, if there were a handle, might leave it running. But by removing the handle from every sink, we essentially presume the guilt of every single person that walks into that bathroom. We preordain exactly how much water, what the temperature is going to be, what the pressure is going to be, and how long you can wash your hands for. Now, I've been in sales for 25 years. Sometimes, occasionally, I need to shave in a public washroom. And that was never an easy thing to do. But with this level of automation, it has become absolutely impossible. In this case, automation has dramatically limited choice and reduced our satisfaction. But there are other situations where too much automation can actually create the illusion of choice. Perhaps my favorite example is the Build-A-Bear workshop. Now, for those of you that are parents or grandparents or aunts or uncles, you know what a Build-A-Bear workshop is. This is a mall store where you go and you take children, where they can actually build their own bear. But what's really happening is the child sits in front of a computer screen and picks the size, the shape, the color of that bear. And then a robot assembles that bear for them. Now, this utopian view of how a teddy bear is made, in some cases, is exactly how we treat the public cloud. Now, I don't think that we're doing our children any favors by allowing them to think that this is the process of creation, that this is how we innovate, that this is how we build things in front of a touchscreen panel. The work of migrating to the public cloud, the work of migrating to private clouds is immense. And rather than charge headlong into a cloud-first or cloud-only strategy, I think it's incumbent upon all of us to recognize that this is not going to happen on a touch panel. That the first thing we need to do is to build the skills to make that migration. And the second thing that we need to do is to be ensure that we're armed with the tools and the capabilities, many of which we've shared with you on these 2 days, so that we can ultimately be successful. And the one thing that I want to absolutely ensure all of you is that as we go through this process of automation, that unlike in the Mercedes metaphor, we're not only going to help you automate the migration of workloads, but we are going to make sure we are committed to ensuring that you will still be able to get under the hood. Now, there's a practical discussion here that we're having, but there's also a philosophical discussion, I suppose you could say. And it's with that in mind that I'm so excited to introduce up on stage our next speaker. He's been called a revitalizer, a remixer of optimism. And he is a television personality extraordinaire. He's a futurist, but above all else, I think he calls himself a philosopher. Please join me in welcoming onto the stage one of the great entertainers, the Emmy Award-nominated host of National Geographic's Brain Games, and one of the few people in the world that can boast 100 million YouTube views. Please join me with a large round of applause for Jason Silva. Jason?